There we go. Now we're live and recording it, so it makes the whole YouTube. So welcome everybody. So a few folks who haven't been for a while, we decided that we would kind of get back into doing some talks. We may get back into doing some hands-on and mix it up. Always open to some good feedback. Tonight, Doug wasn't able to make it. Doug Toppin, as I said, he's on his way driving up 95. So I promised I'd record it for him though, so he can watch it later. So tonight we have Daniel May with us. Daniel May works here at Missouri and has been doing work on a number of different folks, done some work for Smithsonian. But with this project is something that we're doing a proof of concept for State Department. And we got it working end to end with a really cool proof of concept. A lot of good technology that we thought is very relevant to the mean stack. So how many folks here have done some programming in mean? Mongo, Express Angular Node. Cool. So majority of folks. Who's doing a lot of programming in Node? Like that's your primary project? So just a couple folks. Who wants to be doing a lot of programs? That's cool. So we're doing a lot of that. Anybody using React or a different front end besides Angular? Yeah, what are you using? React?
Yes. And also try to React Native.
Oh, you're trying React Native?
Yeah,
well, that'd be interesting. Yeah, there was actually an interesting Angular, or no, it was one of the podcasts that I watched was doing an Angular React talk yesterday. It was pretty interesting stuff.
Yes.
And trying to combine it with Angular
Yes.
at the same time. So
Do you have any opinions about React? Yes.
I don't know it, so so my opinion is that I think with a lot of other frameworks, just like it used to be with the Java frameworks, is you can only go really deep in a few things. And so I would be interested in getting some more depth in React after we kind of master Angular. Angular this year is coming out with Angular 2, which I think many people have probably heard. In the mobile framework, the Ionic 2 is coming out, and we really see that as a major improvement in the Angular framework. That's really going to lower the learning curve. And certainly, I'd say 2/3 to 3/4 of the clients that we come across are interested in Angular as opposed to anything else. So as a consulting agency, it makes sense for us to be really good at Angular and be able to do that extremely well. And so we'll master Angular 2 and then Ionic 2 for mobile deployments. And once we have that, probably at the end of the year, we might be more interested in kind of really comparing it with React. We've had a couple folks of our consultants do a little bit of React programming for PayPal. So that is a good point for me to turn it over while I go down and I'm going to let someone else in. I'm going to turn it over to you, Daniel. You good?
Yep.
All right.
Hey guys, thanks for coming tonight. So basically just going to go over our kind of end-to-end proof of concept tonight. It's kind of rough in some places, so please be kind with your criticism, but it is welcome. So with that, let's just dive right in. So from kind of a high-level view, this is kind of what we have going on here. So we've hooked up some technology to our current facilities here in this building, actually. So we'll see some live data from our server room right down the hall in a few minutes. And essentially, it's sending that data up to Amazon, and we're consuming it on a mobile device and making use of some of the AWS products, API Gateway, Lambda, DynamoDB, and S3 in various forms. So tonight, essentially, we're going to step through it piece by piece. So we'll start with the building IoT stuff. It's kind of boring, but we got to cover it. So we'll then move to the mobile backend services. That's all the AWS stuff. So like I said, API Gateway, Lambda, DynamoDB, and S3. And we'll finish it up with our mobile app, which is pretty simple, but we have high hopes for it. And we are displaying data, so it's pretty cool. All right, so building IoT. So to actually connect with the different facilities here, so we actually, like the air conditioning unit, the thermostats, the fans, the pumps, all that sort of stuff, we need something that can speak basically these machines' languages. So they all communicate on different protocols. So of course it's not easy. But there's a company actually in Richmond that's part of Honeywell International that developed the Niagara framework about 15 years ago is when they started. So with that, they were really pushing for the Baja standard. I don't know if anybody's heard of that, but it's pretty isolated to the building automation, industry. And really, Tritium's kind of probably the biggest player right now that's doing anything that the public is seeing. So, and Niagara is essentially their proprietary implementation of the Baja spec. So, if you want to use it, you got to pay them money. And a little more detail. So, it basically allows us to communicate with all those different systems, the fans, the ACs, thermostats, like I said, in a controlled way and all in one place. So, something called a JACE, which is a Java Application Control Engine. It's just a little module that you can connect, these old pins and wires to, or Ethernet, or anything like that that runs a JVM. So we can actually write custom Java code and utilize that data from those devices. And in a sec, we'll go into a little more detail, see the Niagara Workbench and how it connects to the JACE and how we can actually see that data and how we can customize it. So there it is. That's a JACE. Just a small little box, not like this big. And we have one of those installed, like I said, in the server room down the hall here. And there's plenty of ways you can kind of integrate it into your system, your building, and your network infrastructure. What we have here kind of resembles what's over here on the left. So we have a few air conditioning units, pumps, and that sort of thing hooked up to the JACE, which then connects to our network here. And through the web browser or through the Workbench, we can go in and actually configure it, see the data.
So we have a J6 here. They just came out with the 8, right, or the 7?
I think it's the 8.
Yeah,
it's the newer one.
Yeah, and so that was a major step forward for them too in terms of capacity.
When you say hooked up, you're showing a single wire there. I assume that's not what it's hooked up with. What do you need in terms of outputs on the devices? And
so I think it has like 16 different connections. It's got the RS-232 or the RS-45, and it's got a number of Ethernet ports as well. And it varies. I don't remember exactly how many are off the 6, but as you go, there's like a 3, 4, 5, 6, and an 8 JACE. And as you go up, they have more pin connections to connect more hardware per device. And so you can use twisted wire or the which is the 45 or the 232 RS-232 connections, which a lot of the kind of equipment has. And then some new equipment that, it's coming out today, higher end generators or HVAC systems sometimes have Ethernet, and then you're just plugging in directly via Ethernet and going TCP.
So do you guys have any provision for, let's say, devices don't have Ethernet, or those devices are communicating on their native protocol?
So yeah, so the native protocol, well, you can talk about those too, but there's the LAN, BACnet, Modbus are all common protocols for a lot of the equipment manufacturers. And so basically on the JACE, you have a software driver for each of those protocols, and then it's going to convert that point into a common object model, which is their Java Niagara framework. Yeah, and so there's a 2 sets: the hard wire connecting the wires, where it's Ethernet or the twisted pair, and then there's the protocols.
Then you're going to decode everything.
Yeah.
So you're leveraging their proprietary solution, or are you trying to come up with a competitive?
Well, we're leveraging what they have out of the box, so communicating with these on like BACnet or any of the other proprietary protocols that the places like Honeywell or like your HVAC system probably has some protocol I can communicate on. So they provide out of the box functionality to communicate with those devices. But what we've done here is taken those different data points and we want to send it to the cloud so we can do whatever we want with it, right? So it's not really a competitor, I guess. It's kind of a complement. So right now, out of the box, the Niagara stuff, you can look at all your data points. You can see the temperatures, the fan status. You can hook it up to a power meter and do some power quality stuff like that. But it kind of just sits there on your workstation then. So if you're a technician looking at that stuff, that's fine, great. But we want to be able to take that data and send it up to the cloud so anybody can see it from anywhere.
So it's essentially it's a one-way. We can view the state of the system. We cannot control it from the cloud.
Not yet. In our POC, we're just consuming the data, but in the future, that's actually something our client is interested in. Can they say like reset an alarm if it goes off? Like, hey, the temperature is way above what it's supposed to be, but it's back down normal, but there's still an alarm going off in the background. Can I reset that with my phone, or do I have to go into the office and do it?
Yeah.
So it does support that out of the box, but again, that's kind of a customization that something. Exactly.
That's a good question here. So if I want to control something existing equipment or device, but does not have the interface with the small box, is any third party thing I can buy can hook out so I can talk to the guy?
It's a good question. I'm sure someone out there has built something like that.
Yeah.
But if you have like your dumb thermostat from say like 1990 or something, and you want to hook it up to like you have your own Niagara setup at home, there's probably not an easy way to do that.
Did you run across any building devices that were ready to publish data in acceptable format without this device being necessary?
I'm sure what we have here, we kind of set up, it's basic stuff. Like I said, it's temperature data is what we're looking at. 'Cause it's a server room, so that's kind of what we're concerned with. And that communicates on, I think BACNet's probably the most prevalent protocol that's used out there in the industry. I'm sure some people disagree with me on that, but like I said, since Niagara's been out for about 15 years, that was probably one of the major things one of the first protocols they wanted to incorporate, so people adopted their product. But in terms of consuming it like this out of the box, Niagara's kind of a custom solution to kind of integrate all those into one, so you don't have to worry about, like what vendor am I dealing with? Is my HVAC system gonna talk to, this part of my building or that part of my building? This kind of centralizes that, so you don't have to worry about it as much. All right. And like I mentioned before, the Niagara Workbench. So this is just kind of a screenshot. So what you see here are basically different data points coming in from any number of devices that are connected to your Jace. So it's really dependent upon what the device is. So for example, here, if we see like there's something called his heating, is it a heating element or something like that? It can be really anything that the device is programmed to tell you about itself. And the great thing about, the great and a not so great thing about the Niagara framework is it's built to basically satisfy everybody. So it's a very capable product, but there's a steep learning curve. So you see all these different data points, they're all different. It kind of just, it can accommodate nearly any device. Do you agree with that, Doug?
Yeah, it does. It's kind of a common object model, and so it does. But I don't think there's anything else quite like that takes all the different protocols and normalizes it the way it is into a common object model. And so that's why it's got some popularity.
Okay, so now that we know what Niagara is and Tritium is and what Jace is, what we wanted to do was basically teach Niagara HTTP, so it can talk to the rest of the world. So using the Niagara framework, we created a custom HTTP module that we install on our Jace, and that lets us send this data out to the web. So let's take a look at that real quick. So we'll start here in our Niagara Workbench. So like I said, this is actual data coming from down the hall right now. So we have, some computer room air conditioning systems. They got their temperatures, some minor differences there based on the zone they're in. You can see if it's running. So our number one is in a running state. The other three are in stop states. And then we have some like tolerance levels. So 2 degrees is the tolerance set for that particular zone. If it were to go, say, above the 2 degrees tolerance, it could trigger an alarm. It could send some message. It could shut some stuff down. You can configure that as you like. And as you see here, there's like, 2 degrees Fahrenheit. Okay, that doesn't really, that's just dependent on the device. But so here's our module here where we feed some of this data in. Yes?
Can you just zoom it up if possible?
I don't know. Possible. I'm not sure if we can zoom in on this too much.
May have to
I
walk
guess
up.
you can press control and slide down. That's a window zooming. I'm not sure it's gonna work here.
You can zoom the back side and it should zoom the windows beyond.
Nope. Well, okay, I got kind of going here, so.
There you go.
So I guess, yeah, so here's just a close-up of the driver. So essentially what it is there's an action, so it can send the data somewhere, and then we can hook up as many points to it as we would like. And I know that's not very interesting to look at, really, so let's kind of look a little bit deeper here.
Did you guys build that component or is it out of box?
We built that component. So how can I get, oops.
escape.
Well, okay, anyway. But this is our production system, so I don't really want to, or our current facility system, so I don't want to mess with it too much.
Is that a Windows thing or the?
I guess it is, I don't know. It's kind of going, yeah, all over the place, so that's okay, we can make it work. Let's take a little bit closer look at this driver. So there's a few fields here that we, again, created ourselves. So there's a URL endpoint, so you can point it anywhere you like. Component ID, so when it sends that data, it tells it who it is. Response, so when the server does receive the data, it can say like, good, I got it, or there's something wrong with it, an API key in case you have security. And then there's 2 points hooked up there. They're just random number generators right now, but we wanted to basically make this customizable for anyone in a situation similar to this. So say you have more than 2 points, you can come in here, there's this custom action. You just add a point, it shows up there, and it's just easy as drag and drop. So now that point is being consumed there, and this component is holding onto that data and recording it. And if I want something better than unnamed property, I can come in here and I can actually ask the point what its name is, and I can load that so that it's a little cleaner that way. And I can also manually send the data if, for example, on our system, we have a timer set for every minute it sends the data, and then that data is recorded. And we can also do a test API connection just to see, before we send data, if we are actually connected. So, but that's what it looks like on the front. So from the back, though, it's really just a simple Java class. So using the Baja framework bead component, Niagara makes use of that, so it can actually display it in the workbench, so you get a nice GUI to go with your code. And all this stuff here is Niagara proprietary, kind of how they expect you to come through here and define your different properties. So you remember we had the URL endpoint, the component ID, response. So you come through here, you write 2 or 3 lines of code, and there's a nice little tool up here that you can run that'll actually go through and generate the code that you need to actually get that stuff functional. And it's all formatted all nice with comments and everything else. So, but then for those actions that we were looking at, so if you want to actually go through and make it do something cool, aside from just show you data, it's just simple Java. So for example, when we want to do a test connection, we're literally just reaching into the Java library, starting up a connection. Come on, scroll. Getting the response and sending it back. It's nothing fancy. And the Niagara framework also allows you, if you have some external library, for example, we send our data formatted in JSON. So instead of going through and manually making strings to send to our REST endpoint, we use JSON. We feed it, a map or an array or something like that. It does all the hard work for us. We take that string and send it up. So it's flexible. You can work with, third-party libraries if you have something that does something cool that you want to implement in this framework or something like that. It's possible. And I think.
Quick question.
Sure.
If you have a lot of devices now, do you have a database somewhere it registers or just
Get into that next. So yeah. So what do we do with all this data? So now that we can consume that data and send it to wherever we want to send it, what are we going to do with it? So using Amazon Web Services, like I said before, we make use of API Gateway, Lambda, DynamoDB, and S3 to basically consume, store, and process this data. So from our point of view, what we needed was a public-facing API, a database with a flexible schema based on the data, what the client needs, that sort of thing. Maybe the ability to do some simple data metrics on it, because it's facility data, maybe you're looking for some power quality metrics, or you want to see if maybe, I installed maybe a new server rack. Is the temperature affected at all? Do I need to upgrade my systems to accommodate, this new heat source? And also a place to put the data so that you have some record that you can go back and query and, do whatever you want to do with that. And the tools we found that work perfectly for us in AWS were, like I said, API Gateway, DynamoDB, Lambda, and S3. So if anybody hasn't heard of any of these, I'm going to go through and do a quick, just kind of general, what is it, what does it do, how much does it cost analysis here real quick. So API gateway is basically the front-facing part of AWS that we talk to. So you can set up HTTP. You know, you can do a get, a put, you know, a post, a delete, anything like that. And it's very scalable. So as you see here, like you only pay for when the APIs are in use, and the free tier includes 1 million API calls per month, which is quite a lot if you ask me for what we're doing here. And after that, it's only $3.50 for another 1 million calls. And then the data costs are also nearly negligible.
So I'm sorry, so these API calls are from client to Amazon Web Services or direct transfer between their nodes? And
Do you want to go back to your diagram really quickly and get that back?
because they have different models, I guess. They're saying if you're leaving this to another guy.
Right, so the way we have it implemented, so the JS and all that code, the HTTP driver we just wrote, when that endpoint URL is a place in API gateway.
Oh, okay.
So that's where the data goes, yeah. So it just does a simple post. It's got the data formatted in JSON. API gateway takes it and passes it on to Lambda, which we're about to get to here. So,
Quick question.
Sure.
You know, API gateways need to be. What language do you have to implement your code in the API gateways?
that's a great question, and I promise it's on the next slide.
Oh, okay.
So no worries. So okay, so once that data makes it to Amazon, the place we chose to store it was DynamoDB. And it's because it's a NoSQL database, it's very flexible. And since we're sending our data in JSON, we can just store it natively into DynamoDB just as a string. So the great thing about Dynamo is, again, like it's got the free tier, which has 25 gigs of data for free. And you can have up to 25 read and write capacity units, which is kind of a complicated unit, really, how they charge you. Basically, it amounts to about 1 second of reading or writing 4 kilobytes of data. That's one write unit or one read unit. And if you look down here a little further, some pricing just in case you're curious, but it's very, very cheap to consume data this way. But the other thing about DynamoDB is your data is very safe. So when it gets up there, you know, it's scaled across, you know, Amazon's cloud essentially. So there's a lot of fault tolerance. There's an earthquake in California, your data center is not going to go down. You're not going to lose your data because it's in the cloud. Okay, so now Lambda. So this is where the actual data processing, where you actually get to run code in AWS is. So if you remember back to the diagram we had, so API gateway gets that data and it passes it to Lambda. And Lambda processes that data and puts it into DynamoDB based on whatever, you know, rules you have. And the language, there's 3 different runtimes that Lambda supports: Node.js, Java 8, and Python 2.7. So you can take your pick there. We go with Node.js, and we just do some simple JavaScript, which we'll take a look at here in a second. And all it really does is parse out the data in a way that makes sense to store in a database and puts it there, and that's really about it. It's very simple. And Lambda offers other service integrations with other AWS products like S3 and CloudTrail and a couple other ones. It seems like every month I go on there into the dashboard, there's something new there that they add. So it's always growing. And then S3, we haven't actually integrated this into our design yet, but it's just a database in the cloud. And ideally, it's where we want to put our legacy data. We can archive it there. We can keep it, store it for cheap, you know, because there's a price in there again. As you can see, it's, you know, it's negligible pricing for storing data. And yeah, so that's in the future. Okay, so let's actually go look at this stuff.
Any questions on Lambda? Does that make sense to everybody?
I watched the video.
You watched the video? I have a quick video. That's cool.
Quick question. I mean, what type of processing is it you're going to do with the Lambda versus, you know, you have a driver there on your side, so do you do some processing on the data when you get in and on the AWS side, or what exactly you do? Where do you draw the line?
So where we draw the line is we basically accumulate the data from, say, the server room. We just put it in one message and send it to API gateway, and Lambda does all the processing after that.
Okay.
So our driver is very kind of stupid. It just gets the data and sends it. It doesn't do anything to it. It doesn't worry about if it was received by the API gateway or anything like that. Its job is simply just to collect it and to send it.
Is it a multi-client? On the driver can get, like, you know, whatever the number of devices and simultaneously it can post with the multi.
Right, yeah. So API gateway is very scalable. So
No, not the API gateway. I understand the receiving side and the client side also. You have this JSON controller and all. I think all the data coming to the driver. If you mentioned about
On the Jace?
Jace, yeah.
Yeah, so Niagara is going to handle connecting to many different types of equipment and providing that to the driver in an orderly manner. So
Right.
Is there any limitation? Like if you have a huge, I don't know, the server rooms, the data centers and all, they have thousands of
Tritium will do sizing with you, and so that really is like the Tritium in Niagara implementation. And so a lot of it has to do with the amount of memory that's on the device and the processor capacity. And so that's kind of why they limit to the number of connections. But they have lots of rules of thumb in terms of it. People will connect, 50, 60 pieces of equipment to a single Jace. But then once you get bigger than that, if you're in a very large building, then you have multiple Jaces. And sometimes those will be deployed geographically around the building. But yeah, we actually have a partner that helped us install our Jace here and then does lots of those. So we're doing more of the programming and kind of extending the Tritium capabilities. There are a lot of folks that all they do on a regular basis is install Tritium. So we've got a partner we're working with, and they're very good at sizing those.
I'm basically not on the other side of the infrastructure side, I'm on the software side, pretty much it's system and software architecture there.
Right.
But when it comes to, you need this Jace control wherever in each building. Is there any wireless or non-Ethernet card? If you have a lot of small sensors and all, can you integrate with these Jace, or is there not that far?
So we tend to find in the building, like if you get into people who are managing large facilities, there'll be kind of the IT group that's doing information technology, and we've got things that we do like wireless and all that kind of stuff. The building folks tend to not like that stuff because it's stuff that can be break and it's not reliable, like a Wi-Fi network can go down. So they like wires connecting their equipment to their drivers, and it's much more basic but more reliable. And so they'll, but yeah, you could easily over Wi-Fi, because you could have a TCP connection. So you could have something transmitting over a Wi-Fi, a sensor, and then picking it up on a Wi-Fi receiver, and you could plug that into the Jace over and to the TCP IP connector. The Ethernet connector, and that would work.
Yeah, I'm not sure.
But I haven't seen that done very much.
Oh. I mean, is there no prototype or nobody? I mean, there might be somebody that's a prototype.
There might be. Sometimes the air handlers, like in the ducts, if you wanted to measure temperature in various ducts in the building, there are some wireless devices to do, but even those will talk the protocols.
But it's not a commonly used in that industry.
Not that I know of.
So let's look at our API gateway setup here real quick. So this is actually the post method where the facility data is sent from that driver. So you see they kind of lay it out for you in a nice chart here, but it comes in, you can customize, you can look for specific headers on the request, or you can go through and filter based on those, or add your own if you want even. And then it gets to the integration site, which is where we send it to Lambda. And from there, Lambda kind of does all the data manipulation, stores it in Dynamo, that sort of thing. And then you can also specify your response. So you kind of see how it goes from client all the way around. So you get a nice picture of what's going on here.
Can you do any processing at that layer? Can you munge, change headers, add stuff, take stuff away?
I think you can change the headers. If you, for example, if you're, we looked at that actually. So if there's like an authorization layer that you add to your API, which you should, and we have not yet, that's something that you might go through and say if it's like, encoded or something like that, you want to decode it. I think there is that capability, but we don't make use of it. So, and like I said, there's features being added to this stuff all the time. Amazon's constantly working on enhancing it. So if there isn't today, there probably will be soon, because I feel like I can see where that might be something that could serve some purpose to somebody.
One more question, I'm sorry. What
Sure.
about HTTPS? Can you secure this?
Yeah, so this actually is secure right now. Like I said, we don't actually do any authentication, so please don't bombard us with requests or anything like that. But it does connect. Well, it does connect over HTTPS though, so it is secure.
But authentication is that one of the features available. You just haven't taken advantage of it.
Right. So if we were to take a step back here, we can look at the facility. So we have a get and a post created. And if we wanted to create another method, so we can come over here and you can take your pick on any of the different methods that you like here. But you can see our authorization APIs, API key we're not using yet, but that is something that we need to add soon once we get past this POC stage. But just to give you an idea, yeah. But the post is really the only thing that's going on with our PSC right now, where the data is being sent to AWS and consumed. So next step though is to Lambda. So once it's received by API gateway, it enters this function that we just call log multi-facility data. So it's just a simple JavaScript function. Again, this is running on Node.js. And it comes through here and we just do some basic tests. So for example, we do the test ping. If it's a test ping, we just say, hey, your connection was successful. And that way the driver knows, oh, I've reached the AWS and it's hearing me. And then after that, we kind of split off here and we do a custom Lambda thing. And this is actually where the data is going to be parsed out. So I'll show you an example of a document. So this is an example of a document that the driver actually sends up to API gateway. You can see it's exceptionally simple. It's just, the data fields that we saw there, those points that are connected to the driver and the name of the station, AEM station. And that's all contained just in this event object here. So what we essentially do then is we grab the station name from the request. We go down here, we check the Dynamo table to see if there's an existing record of it. And if there is, we update that record. If there's not, we create a new record and just kind of do some household chores here, just kind of getting the data ready to be stored in DynamoDB, which is right here. So here's basically where we dump the data. So we just put it all in here. We have a name and date key. So right now, the way it's configured for our PSC, we just do every hour, we create a new row. And then it's AEM station and appended by the date and then the hour of the day. Yeah.
So there's a key, sorry,
sure, that's
there's
fine.
a key value pair type of
Exactly.
Dynamo is basically nothing but key value pair.
That's exactly
So your
it.
key is a component ID, or what is exactly key?
Right, so the key in this table here is we combine the component ID and the hour of the day that basically that data corresponds to. And then over here under devices, is actually, sometimes it doesn't work, but we basically throw all the data in a giant JSON object here. So
it's calling once per minute, so there'd be like 60 records per JSON object there for each of those values.
Oh, so basically you get the 60 and dump it to the JSON object and give it a.
So it's interesting, there's a lot of strategies, and if you go out and you Google like storing time series data in a NoSQL or Mongo or something like that, there's a lot of strategies. You could create a different record for every, because we're calling this every minute. So every minute we're getting a set of readings and sending them up here. So you could create a record every minute, but if you look at a lot of the strategies, they'll tell you to take something that's a little more coarse grained than that. So we chose an hour. And so every hour, so every minute when it gets a record, it looks up, and as long as it's not time to roll to the next hour, it's going to look up the key for that particular hour and do an update on that JSON document as opposed to doing an insert.
So basically you had to calculate back to hours. If I wanted a specific minute, whatever I want the data, then you had to calculate where that hour belonged to and get the data.
right. So yeah, when we actually get to a little later querying this database, yeah, you'll see kind of where we have to go through and figure out, okay, do we want it by device? Do we want it by date? Do we want both? Or some combination of the two.
Why Dynamo and not Mongo?
Well, because right now Amazon doesn't put Dynamo or Mongo out there to use. Just kind of, this was literally I created a table and hooked it up to Lambda in about 30 minutes.
The really interesting thing is you could do this all a number of different ways. You could create EC2 instances, install your own node server, deploy your own API, have your own Mongo server, which is the way we've done stuff, and then say we did that for a POC, we'd have one EC2 instance that's Mongo and one that's Node, and that would be it. But you'd be paying for both of those full time. So like a T2 small or something like that, I don't know exactly how much, I'm gonna guess it's in the 30, 40 now, I think. Is it really that much? Somewhere in there, but it's like in that ballpark, right? So you're talking over $100, maybe $120 a month to pay for that. Last month, we ran this full time, 24 hours a day, and we paid $4 for the month of service. So you're paying, when you pay for Amazon services, you're getting a number of things. One, it's a hell of a lot cheaper. Number two, it's a lot more available because like DynamoDB is being replicated across multiple availability zones, so multiple data centers within an AWS region. Whereas that $120 or whatever scenario we described, that's 2 EC2 instances. So if something happens with either one of those instances, let alone the whole data center, it's gone. And you could have to do your own backup and all that. DynamoDB is going to be backed up for you. And so the third thing that's really valuable about a services approach is there's no sysadmin work, right? So we didn't have to go set up an EC2 instance. We didn't have to go do anything. So you're getting something that's orders of magnitude cheaper, more available, more scalable, and you don't have to do any sysadmin work. And so that's where, and there's a trade-off, right? I'm sure we could maybe come up with some. One of the advantages to doing your own EC2 instance is you can do Mongo, because Mongo is not available as an Amazon service. So I need to do an EC2 instance and install it. Mongo's got much better querying capability, and so there are definitely some scenarios where it's nice to use. But we wanted to try this POC using 100% AWS services, and there's definitely a compelling business proposition where I think that the more and more large companies and governments and even small companies and small businesses are going to look at this and say, wow, I'm getting a lot more capability at a fraction of the cost.
So have you guys thought about provisioning Azure, because they have DocumentDB, which is MongoDB copy, and say.
That'd be very interesting. So
index.
we've done a little bit of Azure. Who's done some Azure here?
I mean,
A little bit?
quite heavily, but
Quite
don't think I'm not educating with them.
Yeah.
Just us.
Yeah, no, I think that's interesting. I mean, I think the one competitor right now that Amazon's got coming on, Amazon, in my opinion, still has like 70% of the market at least, if not more. But Azure's doing a good job, especially they have some strong pros for a lot of the government organizations.
So recently they are coming up, if you have a huge amount of data, because data lake, literally they eliminated any limits on it. You can store even petabyte directly.
Wow.
Yeah, I mean, so DocumentDB is essentially just copy of MongoDB, but every field or property is indexed.
Yeah.
That's an added benefit.
And it's a service. It's not something they provide.
No, it's a service. It's a service.
That's great. That's very interesting. Yeah, I know deploying Node on Azure was really smooth and very easy too.
So they're putting a lot of effort to compete with AWS.
That's great. That's better for us. It's going to create more
behind the
better
curve,
products.
They're behind the curve, but that's why they have more learn.
Yeah.
Learn from others.
Yeah.
Pricing as compared to
Competition.
They're very competitive. It's just like you directly, what you're here directly or the way, both have cats. So it's not free lunch in Amazon, not over there, it's like something is cheaper here or something.
That's a great point. Thanks.
Even some clients, for example, you may have some personal preference. They want to store data in somewhere else. So if you can write a connector for them, it's an extra bonus feature for you and business purposes.
Yeah. We're doing some work for State Department, and they're using both. So they use Azure for a lot of stuff, but they're using AWS too. And one of the hardest things is getting the two to talk to each other because they both want to do VPN connections and they both want to be the primary. And so it's interesting.
So when you write, go back to that Lambda code. When you're writing that code, it seems like you're taking away Express. It's like you're just writing Node.js code.
Mm-hmm.
And so how is that? Is it so you have event contacts instead of whatever?
Exactly.
Request response. How different is it figuring out how to write code up there in the Lambda AWS world than if you've got?
So the way I think of Lambda is it's basically just an event container, right? And so when the API gateway gets called, that's an event. If you hook up Lambda code the same way to an S3 bucket, you can do that so that whenever a document would be copied up to S3, you can fire your Lambda code. And so it's very easy because it's very similar. It's, whenever I get an event called, they're handing me that event and saying, what do you want to do with it? In this case, he's preparing it for DynamoDB and storing it in DynamoDB. But it's very easy.
It is.
Yes.
It just seems a little cumbersome switching gears from deploying or setting up your API endpoint or whatever, and then writing the Lambda code, and then actually like going over to another browser tab and seeing if you can actually call it
So there is, I won't touch this computer. So afterwards we'll do, do you remember what that open source framework was that I posted on?
Claudia?
Oh yeah, what's it called?
Claudia JS, I think.
Yeah, so Claudia JS would be another one for you to look at. And that's an open source framework that allows you to define your endpoints in a much more similar to Express type fashion, as well as then your node code.
For this?
And then you run it, and it's going to deploy that and create the API gateway and deploy your Lambda for you. So, and it's I was pretty excited about it because, you know, Lambda is still, you know, just, is it even a year old? Or if it is, it's just barely, right? So this is bleeding edge kind of stuff. And so the idea that we're in a web console to kind of have to put up code, and there's no like life cycle necessarily taking this code through a dev, QA, prod environment type process, the way we have for other continuous integration. It's early, but I think that's coming. So this Claudia was very interesting. That's an open source framework, and I could hook that up. So if I wanted to put this code, or not this code, if I wanted to put something that looked more like an Express, and it's probably still a little bit different, and we can post a link up to the meetup, but it'd be a lot more similar. I could push that to Git, and then I could have a continuous integration build server use something like the Claudia JS, which is an NPM library, and it's going to push it now for me and set this up. And so now I'm one step closer to a continuous integration with Git and my traditional workflows that we're used to. And I think we'll see over the course of this year, we're going to see a lot more of that. And I wouldn't be surprised at all if the next AWS conference, if that was a big thing we saw with Lambda.
So you just say the whole development environment is browser?
Yes.
So what do you do about logging and debugging?
Well, so that's a good question. So here we can just do a simple console log, and I think we should do here. So this is just dumping all the data that it receives just so we can look at it, just to make sure it's all okay. And for development in this environment, yeah, it's a lot of tests. Go to CloudWatch, check the log. What does it look like? And back. There's not really an IDE.
What about like
If I could, go ahead.
The Lambda event? Like, I have to go over and set up an endpoint and then hit the endpoint just to see what I'm going to have to see in my Lambda code, or is there like, is that stuff stubbed out where I can just easily?
I mean, they do kind of have something here, so I can like actually just fire a test event right here, and I can pass it whatever data I want to see, kind of without having to publish it and go through like the whole process like you just described. So like if I want to test this, I can test it right here, and then down below, you know, actually show me like, so there's nothing wrong here, you know, the execution succeeded. But this shows me the log output here. But this is kind of as close to kind of that you're looking at with the Node.js version.
Can you do anything with the CLI? Did you look at that at all?
You can set up like you can create, configure all of your basically all the stuff we've been looking at tonight through the AWS CLI.
The command line interface.
Yeah, so if you're more comfortable on a command line than in a browser or something like that, or there's ways to do it. To me, this is a little easier to learn with, so I can go through and actually like kind of figure out what I'm doing at first. If I could go back and redo it, maybe I'd use the command line interface for some of it. So not that I know of.
I think AWS also provide the SDKs for .NET, Java, PHP, and all the stuff. So we can do all the programming in Eclipse as well as an SDK.
Right. So that's the other option too. If you don't like this, you can upload a jar file that you developed on your own machine or something like that, did all your testing like you normally would, and throw it up here and fire a test event and see it kind of through the browser the same way. And maybe there is some, Amazon command line interface tool that, that I just don't know about. Because this stuff is all new, it's changing all the time. That maybe today you can integrate your testing, your testing cycle.
I think I was reading that one. I think from the command line it has more capabilities that we can do from this one, but for this purpose, this makes more sense to you.
Right. Yes, we're tiptoeing our way through the whole thing, kind of feeling.
Right.
Scroll to the bottom again. So it's kind of two other things just to add to what Daniel said is it's interesting down here. It tells you that it took 220 milliseconds to respond to that. And so that's pretty impressive too when you think that we haven't stood up a node server. So in the time the API got called, it was able to respond back, and that would include then saving it in DynamoDB as well. And so we were billed for 300 milliseconds, which is their smallest block, I think it is. The
100
billing.
milliseconds, yeah, it's the smallest they'll charge you.
And it says here that it's configured to have 100, so it's like a little node container, Node.js container with 128 megabytes. We use 29 megabytes. And so it's just very interesting because it is a little more kludgy to develop in. But when you think about the fact that we're not having to set up that server, and they say they're ready to scale for just kind of out of the box, this endpoint could scale to 10,000, requests per minute or per second?
It's per second.
Per second. And so you're talking about incredible scalability. And if you think about what it would take to test that in your own node environment with a server farm and go through that, that's the reason that this is going to be compelling. And I think the tools will be developed around it.
And why is there that much difference in pricing?
Because I think Amazon, the fact that they can do, so the really amazing thing is that they're creating an endpoint, and without having, they say they don't have a hot server sitting there all the time, so there's no server sitting there. So I could not call this for 3 months and I wouldn't get charged a penny. And then I can call it 1 million times and I still won't get it cost a penny because you get 1 million requests per month within the free. But if I cost it 2 million times, then it's going to scale up for me. And it's going to do that across data centers within an AWS region. That's very powerful. But the fact that they can take one request and they can respond in that kind of time frame, they've figured out how to do that, how to spin up a Node.js container in milliseconds, load your code, respond to, run it, and then close that back down and do that at extraordinary scale. And that's what makes this all possible. And I haven't heard anyone tell too deeply how they do that. That's kind of their secret sauce.
And calls asynchronous. So is your API gateway making an asynchronous call, and then your Lambda's just going off and doing something? What's the return path? Like in your code, if you fail to write to the database, what are you sending back to the API gateway? Is it?
So that context office, or that context object, so here, for example, if it's looking for something that it can't find and it doesn't know what else to do, I just context fail error, and then it sends it back through here, so the integration response gets populated here, and it sends it right back to the client.
Okay, so it's synchronous. It's like waiting for it to return all the way through.
Is it using promises in there? Do you know? Is it using .thems?
Not sure.
Okay.
I think it's a promise, like they're gonna call you back to another channel.
Well, yeah.
And I think the API gateway also gives you the dashboard of how many invocation calls was there and what was successful and what was the hit rate and all that stuff. So all that graphics can also help you in addressing this question.
Yeah,
and the logs aren't being written to a file system log file, they're being written to CloudWatch.
Right.
And that's kind of like a permanent record as well, again,
Exactly.
to the scalability and availability. You don't have to worry about losing those logs because a server happened to drive one out.
Right.
Were you able to crash your node server?
What's that?
Were you able to crash the node server?
We crashed Lambda, or have we crashed a node server separate? Yeah, we've had node servers that have crashed on one project. We're processing really huge PDFs and streaming them, and we didn't quite have the streaming properly. And so if you get into large streams of tens of megabytes, and that can bog down the event loop if you aren't processing node streams correctly. And so things like that can happen.
So one more question. I haven't done anything with Lambda recently. So is there any limitation in terms of resources for Lambda? Like how much memory or compute power they can use?
Well, so we're using just the free tier, so we're limited to like 128 megs, I think, per call. But again, if you want to go up to, like, say you need a lot, like a terabyte, it doesn't cost that much money just to keep going.
So it's a scalable.
Exactly. So when I set up the Lambda function, I specify like the right units, or the time consumption I'm willing to allow. And you see, like, over here on the left, we have like that insufficient alarm kind of going off. So I'm kind of reaching the top of the limits that I'm expecting to pay for. If it exceeds those, right now I have it saying like, it's fine, just take whatever you need and I'll pay for it later. But you can also set it as a hard limit as well. So
are they going to block you when you are exceeding that ceiling limit, or just
as it is now, I've configured it to let it go. So if we do get 10 million requests tonight, it's going to go and I'm going to get a bill for it later. But I can say, whoa, like, do not let it go above this, and users would be, not happy with whatever they got. So. But yeah, that's all configurable when you set up the Lambda function, and I'm sure the CLI probably has some better way to do it than trying to traverse the dashboard and find that little checkbox that you need to find, to set that.
Thank you.
Yeah, I think that is one of the managed services benefit, because it's elastically scalable rather than putting your EC2 instances in auto scaling group and something like that.
I think it depends on the type of functionality type of this one, definitely for it. But the scenarios where you have different criteria, maybe EC2, and you have to go your own. So depending on what you really need to do, you can't just say this is better than this. It may pool around, shared about with a lot of these services. AWS is smart enough to handling. I don't think they have any, as I said, there won't be any dedicated resources. So they're shuffling around 1,000 people like us.
Right.
They use their resources effectively, and that's how they're able to compete with the charge. So
Exactly.
so you win and get, right now it is competed with this, but then, it depends on your usability.
Right.
I think it's going to be a moving target too.
Yeah.
This is going to keep, the right mix is kind of one place right now for a particular system that you're defining today. In 6 months, this is the area where there's a lot of new stuff continuing to come in. It's really exciting.
All right, cool. We'll carry on then. So, and then, okay, so S3 is the part that we haven't gotten to yet, but ideally this is basically where, say, like we have day-old data. It's not going to change. We're just going to need it to query, later in the future for doing metrics. Eventually, we're going to have Dynamo basically do a data dump, or Lambda actually go through, empty out the table in Dynamo, put it in S3 in some way that makes sense to query later, do some metrics, like I said, on. And that part is still to come. So we don't have any really experience with it yet, so I can't tell you too much about it other than we're going to use it. Okay, so
Does that make sense?
Well, S3, or is S3 more like files?
It is.
As opposed to a database.
Exactly, but if you think about what's in DynamoDB within a scenario here, after today, right, we've collected a lot of measurements for the day on what we've done for that equipment. Is that data ever going to change for that particular day? No, it's the same. And so I can write that in the form of a JSON document or several JSON documents, and I can put it in S3, and the query time to just download those, all those things have HTTP URL endpoints that can be secure. And so now I can go through and I could have my Lambda function. So when the API gateway does like we're going to get into the app, it's going to access the data. But when the app accesses the data, that's going to go through an API get command to get that data. That Lambda function could say, oh, is he asking for data from today or from past or both? It could reach out to S3 and Dynamo, bring that together, provide a JSON response back, and that should really lower our Dynamo query times because we're going to really keep that really tight in terms of the amount of data that's there. And S3 is dramatically cheaper than
for data queries. So remember, it's your charged on your capacity, read capacity, right? So if you're querying to like 10 years worth of data, you're going to max out your whatever provisioned, read output is for Dynamo, and probably end up costing a lot more money than if you were just to do a single.
But S3 is basically going to be faster and cheaper.
Yes.
And with S3, you could go a step further and you could say there's Glacier, which you can basically can take an S3 bucket and say, all right, for data that's more than 2 years old, I'm never going to go look at it again, but I don't want to delete it. But I'm never going to go look at it again. So you let that roll to Glacier, where it's a 10th cheaper, or whatever it is. I don't know how much cheaper. It was a lot cheaper, order of magnitude again. And that's kind of put away. So now I can have this life cycle of data that's completely automated, is extraordinarily inexpensive, extraordinarily high availability and scalability, and I don't need a sysadmin involved.
And you can get that in probably back in 3-5 hours once you request it.
Right,
well.
if you need it. If you do a lot of that, it starts to get expensive.
And if there is data which is something reproducible, you can put it into reduce redundancy and all those stuff. So
yeah, so we could leave it in Dynamo if we wanted to. It's not that we have to put it in S3.
I mean, it'll give you a lot of options to kind of save you money.
I would have thought it's more for the amount of work to archive it out to S3, just leave it in Dynamo.
Actually, it'd be a lot cheaper. And really with Dynamo, we're finding we're going to have to do, Dynamo's taking like sometimes, and it might be the way we're saving, but it's taking over a couple seconds sometimes for us to query.
So it's like for our data, it's time series data. So obviously the data is the primary way we, kind of index it. So you can add as many indices as you want onto your DynamoDB table, but you're going to have to provision writes and reads for those, and that's going to end up costing you. Right. So if I'm trying to go through, like I said, like a decade's worth of data, I want it all ordered by the timestamp. That's a lot of, you're going to pay for that. Whereas we can throw it. Go ahead.
And if you want to save more money utilizing more S3, you can keep the data in S3 and put the metadata in DynamoDB, so that DynamoDB can, you can use that metadata to query and then put that index from S3 and retrieve it. So it's even a better architecture.
It can be very, very fast. And then S3, you can also use CloudFront, which is their CDN capability. And so not only are we not doing a database query lookup, but now we're actually cloud using CloudFront to push the data out. So depending on but the whole point is you can combine these various services to start to, and so not to think just traditionally about just doing it the way we've always done it with a 3-tier architecture, and that's the only way to do it.
So your queries are, sometimes you've seen slow queries.
And so we're getting better at DynamoDB.
I mean, how many records? You're only putting tens of thousands of records there?
Well, it seems to kind of like it'll go up in time, but it kind of bottoms out, and just kind of no matter how much more data you have, around 15 seconds is kind of when it's like, okay, you can get all the entire database or most of it or a lot of it. And that's kind of what we're seeing. We could probably do better if we just, were to index the data a little better or to store it in a different format. But for the POC, just kind of what we were playing with, we put it in there and it's acceptable. And in a sec, we'll see on the mobile app, you can query like, 3 or 4 days worth of data for any device and you don't even notice it.
You just populate S3 and the database at the same time.
So I guess that would be a design consideration.
We haven't done S3 yet.
Yeah.
Oh, okay.
So that's
when the time comes, maybe that would be the better way to go.
And both places.
And then just dump the DynamoDB table at the end of the day. Maybe that would be better. Or if we want to do like one of the Dynamo streams, or where you actually can, maybe utilize that. We don't know. We haven't done it yet, so still deciding on that one. But
so how long? Like in the past era, you were actually keeping in there. I know it's more like design decision. Like a week worth, a month worth in DynamoDB.
Right now we've got what, 2-3 months? How much do you have in there right now?
I kind of deleted some of the old stuff.
Yeah, so about 3-ish months.
Yeah, probably 3 months total. And
but you mean how long would we do for our design?
Oh no, I say it's a design decision, like how long you want to keep it.
Right. Yeah, based on the client's
needs. Per hour per device, or a record per minute per device?
It's a record per hour per device, and each record has 60 minutes worth. So we're appending another minute onto that JSON document every time we get one in.
Oh, you're adding to the document.
Yeah, okay. Every hour.
Yeah, and like if you said, as I said, if you Google time series data and then NoSQL database, you'll find a lot of good guidance out there in terms of how to structure your data model for time series data. Mongo's got some really nice papers on it. We looked at their papers too when we were doing that. And again, this is just a POC that we've done in a few weeks, so those are definitely areas where we're very interested to go back in and learn a lot more.
I'm sorry, one more question. Is DynamoDB column oriented? Just key value store?
It's column oriented.
So you can add more column rather than just appending to.
You
that
could.
would be much faster to retrieve it.
Maybe.
Just,
so most of our experience.
Is it SQL?
No, it's no
SQL.
It's not SQL format.
It's DynamoDB columns.
Yes, that's correct.
So it's not SQL. What do you mean that column? That's very confusing.
Yeah, it's not a SQL column. It's like, so I have a key value pair, but it's like a key in many values.
Oh.
Where each of those values is a column.
Oh, okay.
There's no fixed length. Like
there is no structure.
Okay.
That's to begin with. I think the one major distinction between Mongo and Dynamo NoSQL is you cannot have nested key value pairs. So that is something if you want to compare that.
You can have a JSON document that had nesting, but you're not going to query off it like you can in a Mongo, and you can't create indexes, as far as I know. And so we're really, we're pretty good at Mongo. We're just getting started with DynamoDB. This is our first foray into DynamoDB.
Actually, Amazon does provide another service, which is I think Kinesis services, which is like if there
ingestion.
Streaming of the continuous stream of data coming to your.
Yep.
But in this scenario, you have continuous stream of coming from multiple devices. So what do you think? If you think about this project as such, was there any? Have you guys thought of
Kinesis?
Those, or what are the pros and cons of using that in this particular scenario?
So I don't know. Really the use cases I've heard of Kinesis is, if anybody doesn't know, it's an ingestion service that Amazon has, and you usually call it with some sort of client, one of the various, they've got different language clients or the CLI or whatever, and you can push data into Kinesis and it can scale to handle ingestion of very large volumes of data, and it guarantees that it's going to keep that data for 24 hours. So you have 24 hours to get the data out of the Kinesis stream and put it into a database, or a lot of times people will pull it out in multiple. They'll populate their data warehouse and a back-end database at the same time. And to me, that just feels like a larger scale type implementation. The one thing that we see as being very valuable is having an API. And so having a REST API so that you don't have to have an AWS client library to send that data in, but that we can just say, hey, here's the REST API. And I think a lot of external partners, if they wanted to develop, say, their own app, like a customer wanted to develop their own app internally, they had their IT group, and they want to say, hey, I want to do something with our building data. So they hire us to collect all the building data, to store it in for them in the cloud, and they pay us like a monthly service or whatever to do that, and we take care of all that. And we might even have a mobile app that we can say, hey, here, you can use our mobile app and you can work with the data, you can do some analytics or whatever. But then their IT group say, that's great, but we want to pull that data directly and we want to put that in our own SAP system, or we want to do our own dashboard that we're doing whatever, Cognos or what have you. So that's an area where I think having that API is really valuable, because we can say, all right, here's the API, and then look at that, and, oh, that's great, okay, we can consume that, and that's going to be pretty easy to use. So we haven't got anything big enough or voluminous that it would kind of cause me to go from an API-centric view of that interface to a Kinesis-centric view of that interface. Right. It'd be an interesting conversation to have with the AWS guys, though, to have that exact conversation.
Right.
I know they're dealing a lot where they're pulling in like huge volumes of log file data or what have you, that kind of stuff, and that's just like a classic use case.
I know the real world, I think more ETL, close to that type, I think people are heading toward, but even this is more of even data versus the logs and the dump.
Yeah.
So that's where I think
that's where Kinesis comes in, and this is more at the app level.
Right. I mean, anything can be used for anything else, right? But in reality, it's more analogy-wise. This is more of the event. Some data comes in, you dump it. Right?
Yeah.
It's like a key value, however you take it. Where that comes in, streaming a large chunk of data, and as you said, like an ETL-driven type. More data warehouse and the input to the data warehouse.
All right. Really good discussion. All right, so now let's go to maybe the more interesting side of things, the mobile app. So for the mobile app, we basically just needed, well, maybe I should put this slide first. We needed an app that could fetch the facility data from AWS and display it in some meaningful way to the user, so that it's not just data somewhere in a database in the cloud. So we decided to go with the Ionic framework. So we have some experience working with it. We just used the starter tabs template. It was very easy to kind of get up and running. It's very little time. And display is just some basic time series data for the test station that we have set up. So if anyone, I don't know if anyone here has worked with the Ionic framework at all.
Anybody? Oh, that's right.
Okay. Well, you haven't, you should, because it's really cool. And it's actually, there's over 1.2 million mobile apps out there that have been created using it. So I'll take a look at it right now just to give you kind of an idea of what it is, what it looks like, what it does. So it's, it's just a basic JavaScript framework that you can use to create mobile apps. It's built on top of Apache Cordova, and it uses AngularJS, backend. And it comes with all these great little things that you can use that are just out of the box. So let's look at some good ones. So for example, a list can be boring. You can add headers to it. You can add icons, and all this stuff is straight out of the box. So you don't have to go hunting for your own fonts or your own icons. It's got special classes like item icon right, so it automatically aligns it to the right. That sort of thing. Comes with basic stuff, like check boxes. It's got select options, so you can come through here, and it's stuff that it looks neat, it's cool. You don't have to do it yourself. And in the future, Ionic 2 right now is in beta, but it's getting even better. So now you can actually come through and write the code once and specify the platform, or auto detect the platform, and then based on it's an iPhone, Android, and even Windows phone, you can come through here and if I expect like the iOS. Come on. This again.
That's coming.
So for example, like tabs are between iOS at the bottom, and on Android they're at the top. So these two layouts here are generated by the exact same code. It's just you specify which platform you're running it on, and even Windows Phone. Well, maybe not.
Is that paid service?
Ionic right now is free.
Free.
And I think the actual, this part of Ionic, I believe, will always stay free. If you go to ionic.io, they've got some value-added services that we're using, and so those are really nice. They've got an Ionic Analytics, and so you can install their analytics, and it will send back usage data of how everybody is using your app and give you dashboards. They've got a deployment capability that allows you to update the app without having to resubmit it to the App Store or the Play Store, and so that's a pretty cool capability. They have a deploy, so if you have a dev, test, and production version, and that's in beta right now, and when they go to production for that, they're going to charge for that. I don't think it'll be very expensive. We're using it for a commercial app that we're doing.
They're charging for random users.
Yes, and so be value added. So, but I think the framework, if you were to do it all on your own and deploy it all on your own, I'm pretty sure they would be committed to keeping that part of it free through Ionic too. And they're definitely got some, you know, we've tried this, we tried PhoneGap, and the Ionic guys really are in lockstep with the Angular 2 team too, and they're coming out with their announcement soon. So
No offense to Microsoft or Oracle if they are not buying.
what's that?
They don't acquire.
Yeah,
No, I'm saying no offense to them. If they plan to acquire, they may charge.
yeah, that's right. That's right.
So you tried to use Angular material with it.
I think Microsoft recently
It did not work very well. We had to back out of it and go straight Ionic.
Is that Ionic 2 or?
Either Ionic 1, Angular material is Angular 1, and it did not work inside of Ionic 1. We had some performance issues, and a lot of the transitions, which is the animations and the transitions between them, got to be pretty bad. And one of the big things you're getting with Ionic and a lot of different frameworks on the mobile side is that they work on a lot of different devices. And it's not just Android and Apple or iOS, but it's the iOS 6, 6S, the 5, you know, the 5S, and then you've got all the different plethora of versions of Androids. And so we really found that trying to step too far out of the box, you really want to do that slowly as you get good at it, and try and use the out-of-the-box functionality, which is going to work consistently across many platforms. And that's working. That strategy is starting to work well for us. We tried to go a little bit too fast at once last year. We backed up, and we've been doing great for the past 3 or 4 months.
How about performance?
Ionic is, yeah, like I said, if you stay within Ionic, the components that Daniel just showed you, the performance is great. It's very snappy. And we have in fact, we have an app that we're developing that we're going to put up on the App Store, I think, next month. That's going to be a public app, and so maybe we'll do a Nova Mean on it sometime in the summer, and we can go into it. But it's doing complete personal financial management, and it's very responsive. So I've been very happy with the performance of Ionic.
How do you get an app on the Apple App Store? You have to go to Apple and get a...
Yep, you have to get a developer account. You build it just like you would if you were in their native Apple app, and you submit it.
So it's kind of like the Cordova CLI, the command line interface. You just do Ionic build iOS. It generates the Xcode project. You launch it up, product archive.
The IPA, and eventually it's going to produce an IPA, and you upload that file. You have to digitally sign it, and they walk you through that whole process.
You better compile.
So you probably use the same code for building the same application building and just deploy
Exactly.
it to
Just
two
a-
app stores.
Yep.
Hybrid application. So yeah, there's even BlackBerry 10 support, I believe, and Ionic 1. So and Android and iOS, obviously.
And for this app development, what kind of IDEs and emulators so that you can test those functionalities? What kind of emulators do you guys use to? Because in Android or Xcode, they do provide with the emulators.
Yeah, so I guess I've mainly done iOS, and when you test your app, you're kind of testing it on the JavaScript and the HTML level. So you can use any of those testing frameworks, but when it spits out like your iOS app, you kind of have to go through and I don't know of any way of maybe if there's some testing framework you could use, but it kind of wraps your application in a web view, and it's just displaying the HTML. CSS and stuff.
Okay, so you probably can test it in the browser as well.
Exactly.
Okay.
So yeah, usually the developer workstation, you're testing it in the browser as you're getting everything working.
Right.
And then we run it in the local iOS emulator. That's your iPhone emulator that runs on your laptop. And then you can connect your iPhone or your Android directly to it. And if you do a run there and it detects the phone, it'll actually install it on the app. And then you're running it there.
Right.
And they've got one other kind of intermediate stage. They have an app called Ionic View, VIEW. And you can download that from the App Store and the Play Store. And then with that Ionic IO service at the command line, you can do Ionic space upload. And it will upload kind of an intermediate version of your app to Ionic View, and other people can pull that down on their phone for testing. So as we're developing an app, we've got a dozen different folks in here, business folks, some technical, some QA, and we do a first round of testing using that Ionic View app, and it's great because whenever we want to push a new version of it, it's just the developer just does Ionic upload, and it's available to everybody.
Right, it's a good framework, like good application for the feedback. So.
Yeah.
So they're running the Ionic View app on their iPhone?
What's that?
They're running the Ionic View app?
Yes, in that scenario, they're doing the Ionic View app. Now, you could go through the process of actually doing a normal build, like an IPA and an APK, and deploy that out through the more formal kind of test approaches that you can do through those Play Stores. They're all third parties that'll manage that for you as well.
So with Ionic, do you have access to like components of the phone, like the camera?
Well, so that's a great thing. So it uses PhoneGap or Cordova plugins. So for example, we have one that uses the flash on the phone and also the camera to scan barcodes and that sort of thing. So if there's a PhoneGap or Cordova plugin out there, it works with Ionic because it's just Cordova, just a fancy wrapper around it.
And then what about access to like the data that's on the phone?
Same thing.
Facebook, images.
Yeah, so that would be another like plugin you would have to find, and there's hundreds of them out there. So most of them are free, but I know like with PhoneGap, like there's some premium ones you can actually pay for that are probably a little more polished. But things like that and like integration with other apps and that sort of thing, it's all just plugins that you'd have to go out and find and integrate with your application.
And some of them work better than others. But I mean, certainly for the phone and getting your position and kind of common things like that with GPS, those are pretty standard and work really well. Ionic, as a part of Ionic 2, is coming out with something called Ionic Native that's going to compete with Cordova, just because they'll still support Cordova plugins, but they want a small set of very high quality that are very easy to use plugins just to make the development that much easier. So you'll probably hear stuff about that if you get into Ionic.
And I guess we kind of touched on the Angular part, but again, Angular is a big part of that. So, all right, so let's take a look at the mobile app.
Let me bring up that. So I think NGConf is in May 5th through 8th, something like that. And I think a lot of folks are expecting Angular 2 to be announced at NGConf as publicly available. And I think Ionic 2 will probably get become available too then. And they're major, they're almost like new products in a lot of ways. Build on the same concepts, but
yeah, I'm sure so. This app is not meant to be pretty or fancy or anything. It's just so very simple. It's just the AM station. Uses the same 4 components that we saw over here. So those are the parts, and there they are right there. So the idea is you can come in here and select it, and if there was data for today, you would see it right there. But we have, for our testing purposes, I think this is the last full day we have data. So, but you see like the daily average was 70 that day, and then you can come down here. You can drill down to, say like you want to see what happened around noon, during lunch. You can come down here and you see like the 15-minute increments, averages, and you can drill down to the 1 minute if you want to see the raw data right there. So it's not pretty, obviously. It's not probably enough. It shows the data, right? So that's all we want.
We're showing end-to-end connectivity.
Yeah. So it proves the data can go from our building to your phone anywhere. And in the future, obviously, we want to enhance this to make it a little more usable. Like this calendar thing is okay to pick a date. But what if you want to pick, multiple days? You can't necessarily go and do a metric like what was the weekly average. Right now, the way it stands. But yeah, so this is just a basic Ionic app. Like I said, it was the tab template starter. So literally just came through and ripped out the tab stuff and added our own Ionic list here.
So from phone, you're going to what services back to Dynamo? From Dynamo, you're pulling this.
Right. So the phone here we can actually walk through it now. So, but here's the app.js. It's a very simple setup. We have 3 different screens. And so your question, where does it go to get the data?
This is the whole Ionic project directory here.
Yeah, right over here.
So this is the code that's running on the phone.
Right. So we just do a simple post to our client up there. We tell it the station we're querying for, just POC. The data comes back, we load it locally, and then we can do whatever we want with it. So for example, with the daily, the hourly, and the 15-minute averages, that's all this is doing here is just taking that data and churning out some metrics on it.
You get the whole 1 hour data and then you process it here? Or?
Right, so it empties the database the way it stands now. We have like a couple months worth of data. I think we're working with 3 days with it right now, just to show. But yeah, it comes down, and the thing with the flexibility here, so in Lambda, we can actually change the format of that data that's sent down to the device however we see fit, without having to update this application or anything like that. So we're kind of doing data manipulation in both places right now. So in Lambda, we're kind of taking each device and going through basically the dates and saying, okay, like here's all your data that you know of, and sending down to the device. We could instead maybe format it a different way and send to the device that way, but that's just kind of design decisions.
Yeah,
so because you're paying.
As long as you can do that.
Right. Because the benefit there is the device doesn't have to do a whole lot of complex.
Yeah, that's what I was trying to.
But then you're paying for the compute time while you do those. Every time someone needs that data, I got to go through and calculate the daily averages for God knows how many devices.
The wireless data and other things also will impact the data.
So then another strategy would to do all those calculations once and store it in S3.
Yeah.
Because S3 is so incredibly cheap.
Right.
And then go through, and so if it already exists in S3, give it that. If it doesn't, go calculate it and stick it in S3, and you're kind of using S3 as a cache in that sense.
Yeah, obviously, because once again, you're using the mobile capacity and then the data.
And you're flexible too. If you have this API gateway, right, and it's got a contract then between people that are submitting data and things like the mobile device that's getting the data, you can keep that contract, and then behind that, how you store and update the data, where I want to do DynamoDB 100% today, and tomorrow I start using S3, or I start using other services. As long as that contract stays the same, I can do whatever I want.
Yeah, and then maybe even, I don't know, it depends on what level you want to go to architecture. If you want to have a lot of queries coming in, keep 1 day worth of the mem cache.
Yep, you can do mem cache, sure.
Cache there, so that way you use it and then use, but it's still the combination.
You could use Elasticsearch. There's all kinds of things we can do back there in the cloud.
In fact, I think Elasticache, they already have a service called Elasticache.
Yes, they do.
They use Memcache and Redis both.
Yeah, and they have Elasticsearch with another product for doing Elasticsearch, which is another kind of searching, fuzzy searching type thing. So yeah, versus the in-memory caches.
Yeah, there are various options there, and they look at what the right fit.
Yeah, it's the fun part. So yeah, and here you'll see just like the basic. We got Angular working with Ionic. So remember we saw those those CSS components. So here's an Ion list that's displaying all those things, and they're collapsible. So you come through here, and you have your hourly stuff right here, and you can click on each one. And when you do it, where is it? NG click.
Right there, you're on it. Toggle group hour.
Oh, you're right. So toggle group hour. So toggle this hour group, and it goes through and it expands this list here and further down to the minute data stuff. Yeah, so that's essentially, you see the Ion item there working with the Angular stuff, so it all complements everything very well. And let's see what else is there. I think that's it for the mobile side.
So do you guys have any, let's say, animation, or people love face values on colors on their screen?
Yeah, so
more colors, even you are not displaying something like, oh, that's cool.
So that's leads into your next topic, right? Where we're going from here.
Good thinking, yeah. Okay, so basically, so that's where we kind of stand now. So a roadmap from here. So we need to make some improvements on the Niagara side. So for example, right now it's fire and forget with the data. If your power goes out and your generators will turn on your Jace, what happens to that data? It gets lost. So we need to be able to cache that data locally and wait for the next connection, do a batch update. And also, I don't know if you guys noticed, but the way it was firing was just a simple little toggle in the background that every minute it would just basically flip a switch, trigger the send data. We'd like to be able to make the HTTP component itself kind of able to set its own timer. So the Niagara framework has so many things that you can do that that's something very simple that we need to add to ours to make it really kind of fit in with, you know, the Niagara stuff, because there's just so much capability that we're not even using. So, and something else we're kind of toying with the idea is maybe making the data format that the component sends to AWS configurable via AWS. So maybe we send down like a template or something like that we want the JSON, you know, configured this way. And the app's like, okay, well, I'll just change the data I'm getting to send it that way. If, like Doug was saying, like, you know, you can't break that contract, but maybe you can bend a little bit, or if they're like, hey, like, we'd like to have a little more data, we don't have to go out to their facility and install a new driver on their JS or anything like that. We can just kind of update stuff, you know, from our desk on the AWS console. And AWS improvements, like we said, make use of S3 in some fashion, at least to move some of the older data there, so it's easier to query, you know, in bulk. Yeah, I'd probably do that with Lambda, and kind of decouple the Lambda functions too. Like the first time we wrote it, we had one function doing everything. We've kind of gone through a few iterations now where there's like a Lambda function that receives the initial request, and then from there we can fire other Lambda functions based on certain criteria. So.
Yeah, that's my question. If you want to run some background jobs later in the day, so you can have a timer set and do it on a amount.
In Lambda?
Yeah.
That's a good question. I think there is a way to configure it to run on times, but it's really kind of, I don't know if that's what it's kind of designed to do.
I think it will be.
Yeah.
I'm trying to remember if there'd be a way to do that too. I haven't looked. I've thought of wanting to do that too, and I just haven't gotten around to looking for it yet. But a lot of it's going to be event based. So can you postpone some of those things that you might do regularly and have them being triggered off some event?
Yeah, it's outside maybe.
And so, but there could be cases, and you may be able to do that now. I don't know if you can trigger Lambda via timer, but it wouldn't surprise me
too much. But
so basically, you have to send a signal out from outside. Yes.
you certainly could do that, yeah. Or you could spin up an EC2 instance and put a cron job on it, and have it fire an SQ. So the queries, it's got like a messaging SQS is their querying server, and that can Lambda can respond to SQS messages. So if nothing else, you could have a tiny little server just firing off an SQS message once a day, and that would do it. But I bet there are probably better ways to do it than that too.
I'm sure, I guess AWS should have this very common service.
Yeah.
Somewhere.
Lambda started out with just like 2 or 3 things. So the API gateway itself is less than 6 months old. Lambda being able to respond to that's very new. So this is, you know, this is really the latest and greatest in terms of stuff.
Just one comment on point number 2. You basically want to archive the old data. So what about there is in S3 there is a life cycle management. You can basically archive your data.
To Glacier and stuff.
To the Glacier and stuff.
Yeah. Oh yeah, definitely.
So don't you think that is something which can be done for the point number 2 there?
Absolutely.
yeah, these are just things that we think that we need to
Yeah,
improve.
I think based on what extent it is, I mean, S3 is still, you know, how long you want there. Glacier is still, it's just the archival purpose.
No, I mean from the S3 itself. But my point was, you can basically configure like after how many days.
Yeah.
Maybe it has be in 60 days. I want to archive it after that. There are capabilities you can do that on it.
Absolutely. Yeah, very flexible. It's almost so flexible. It's taking a while to get used to it and start to, you know, use it, because we're used to just the 3-tier client server database architecture. So.
And of course, mobile improvements. So something like you said that's not very pretty, but something to maybe make it look better. There's a library called dc.js, which is a mix of D3 and something called crossfilter. And I'll actually show you guys here.
Has anybody looked at dc.js before? That's pretty cool. Have you heard of D3?
Yeah.
So it's a graphic library.
Yeah, so for example, here's the NASDAQ 100 index during that time range. And if you watch, like, we can actually go through and all these graphs kind of respond to each other.
So if you want to filter the data by Q1 2001, it just filtered, how many years of that? 1985 to 2012. And all this is happening in the browser.
Yeah.
And so that's usually been the land of, you know, BI tools on the back end. And so
Yeah, so if we could make use of something like this, maybe not, this beautiful and amazing, just because it's basic, temperature data essentially. But there's a
and if
bunch
you're
of other
interested in that,
examples
that's
too.
actually an interesting one to bring up on. Oh, is that one? Oh, you just the different. Yeah.
So see, there's so many different things you can do here. They have plenty of different types of graphs to choose from depending on the data you're trying to get, I guess. So.
But it's all time series? Yeah.
So the way this works is the cross filter was a library that I think the guys at, was it PayPal?
I think it's PayPal or
I think
Square.
PayPal or Squarespace was it?
Square Registry, yeah.
Square. Developed this ability to just basically take in like a tab delimited data set, flat file of a lot of value, and they're doing dimensions on it across various dimensions as they load it, which makes it very then fast for you to click on these other dimensions. And then the D3 is reacting to that. So the integration between multiple D3 graphs so that I can click on maybe a days of the week here, I can see what my volume is days of the week, but if I click on the day of the week, it's going to then tell the other D3 graphs to filter based on Tuesdays and only show me Tuesday's data. And so that's cross filter that's doing that very quick kind of slicing of the data. And then DC.js is combining together a number of out-of-the-box D3 graphs charts. And so if you actually look at the view source for that first one, it's not that bad. It's like 3 or 4 pages of source code that's reasonable to follow. D3 has a little bit of a learning curve, we've found, definitely a few weeks to really get comfortable with it. And we'd be happy to go into that more sometime too if that's of interest. But yeah, but I think the DC.js, again, using this proof of concept approach that Daniel's been using, I think we'll be able to add some color and whiz bang and some more value to that data that we're collecting on the facilities, right? Because now we can say, all right, if you have 24-hour time, what's the temperature across? Now just show me what it's like at 7 o'clock at nights across the past few months. And building person that wanted to maybe dig into that data and understand what was going on, this would be, I think, a really good first place for us to provide that.
Yeah, this is kind of our sad D3 graph right now. You see there's a lot of data missing because it didn't make it to AWS. Well, so I mean, we can zoom in here and you see these data drops where there's just missing data, but we can zoom in, you see the time scale on the bottom, slowly adjust. So, and this is 3 days of data, 3 days worth of data, every minute. So it's not.
So do I need to know the D3 in order to use a DC?
At least at a high level. It definitely is going to help you if you want to take care of some of the out-of-the-box charts. They've got some out-of-the-box charts to do that. And there's other D3 libraries. There's C3JS and there's NVD3. If you Google just D3 libraries, and if you're interested, then pop it up on the forum.
You never can just use one. Use them all.
Is Elasticsearch also cheap?
I don't think Elasticsearch is cheap, but I don't know. I've just been they've been in the press a lot the past couple weeks. So I have not actually used it, but that would be another capability.
I think we can start a GitHub project as well, probably with Iconic and D3 integration and try to create one application on top of that. Where whoever is interested can really contribute to that. So that would be a cool thing to.
That would be very cool. Maybe do it as an Ionic app and just embed it all into Ionic.
Yeah, and push it in the app stores and see how it goes.
All right.
Weren't you guys working on that before?
Yes, we did. And we got through a decent app by the end of the year, but there's more that can be done on it. But I think
it's tabled now.
Yeah, it's tabled. Let's get any more questions?
It was great, thank you.
Good. Very good. So thanks. Very good. I appreciate y'all coming out. Is there anything in particular you'd like to see in the next couple months?
I think the application.
What's that?
Yeah, putting a GitHub project and probably starting something.
You want to try doing some hands-on stuff?
Yeah, that would be cool.
So we can try that in between. Cool. We've got our GitHub site up there. We've got all that infrastructure in place. We've got a NovaMe GitHub account.
Right.
All right. See if we can get that.
Public?
Yep.
Is it open?
Yep. So we can create a quick tab starter project and put up a quick how-to in the front page of the GitHub. and put out a link. That'll only take half an hour, so you can do that pretty quick. And then everybody could play with a lot of this technology that we're looking at right here. What's that? We will post the slides out, so we can make the slides publicly available. Is that? Oh, you're talking about the links for the app?
Just in general.
We're looking for the source code for all that.
For this one, right? Definitely bits and pieces. A lot of it's actually not that hard to recreate, believe it or not. So in a lot of it are bits and places, but cool. All right, well, maybe probably do a quick survey out there, and we'll see what folks want to do.
What's your color scheme you use in Redstone?
Sorry.
Yeah, color scheme.
Go ahead.
You guys mentioned about
Unique to you, or?
I guess we'll let everybody go. It was good to see everybody. If you want to sit and talk for a little bit, please feel free.
So can you add
Just how it
some
colored.
companions, like the storage maybe?